We're now going to look at a more complicated version of rationalising the denominator. Let's take this example here. We're to rationalise the denominator on 5 over 2 minus root 3. Now the basic principle is the same. We still need to get rid of the surd in the denominator. We still don't mind if we get a surd in the numerator at the end, that's fine. But the denominator is now more complicated than examples we've looked at in the past. We still use equivalent fractions, so we still multiply by 1. We still have to get the denominator right, so that when we multiply these denominators, the surd will disappear. All of that is still true. The problem most people hit is that they are used to putting in here whatever they see in here. So they automatically write 2 minus root 3. And then they automatically write 2 minus root 3 up here as well. And it doesn't work. Because the rule is not to put here whatever you see here. Rather, the rule is to put something here that will do the job of getting rid of the surd. Now let's just take a look at what happens if we did use this. I'm telling you now it won't work, but let's see what happens. First of all, remind yourself that in a fraction, every numerator, every denominator is actually in a bracket, although often we don't need to write them. Now let's just take a moment to look at what happens if we expand 2 minus root 3 times 2 minus root 3. We've got 4 minus 2 root 3 minus 2 root 3. Negative times negative makes a positive, root 3 root 3. And so we've got 4. They combine to make minus 4 root 3 plus 3. So we've got altogether 7 minus 4 root 3. That is what we would get on the denominator if we multiplied those. And you can see the surd is still there. Choosing this in the denominator here has not got rid of the surd, and the denominator has not been rationalised. It's completely useless. So it is not the right choice. So I'm just going to get rid of that. Instead, we have to use what we know of the difference of two squares. And we, rather cunningly, put a plus there instead of a minus. Now this is the right option, so I'm going to follow this through. 2 plus root 3 in the denominator, but we have to multiply by 1 overall. So I have no choice now but to put that in the numerator. Let's see what happens. The numerator, 5 times the bracket. There's no particular problems there. By the way, I wouldn't recommend that you expand this bracket. We'll see why perhaps later on. It's generally not worthwhile expanding the numerator. In the denominator, we've got 2 times 2. We've got 2 times positive root 3, so positive 2 root 3. We've got negative root 3 times 2, so negative 2 root 3. And we've got negative times a positive, root 3 root 3. Which means that in the denominator, we've got 4 plus 2 root 3 minus 2 root 3. Those cancel each other out to make 0 root 3, or just 0. And we've got minus 3 tagged on the end there. So we've actually got 5 bracket 2 plus root 3 all over 1, which is better written as just 5 bracket 2 plus root 3. We've rationalised the denominator. It actually worked out as 1, so we don't even need to show the denominator. Now, you try this second example, rationalise the denominator on that. If you pause the video just now, then I'll go through it once you've had a go. Okay, hopefully you've had a go at that. We're going to multiply by something which means 1 for the sake of equivalent fractions. We can see a plus here, and so we're going to choose 5 minus root 2, so that the difference of 2 squares will work in our favour and get rid of the surds. But if we're multiplying the denominator by 5 minus root 2, we've got to do the same to the numerator as well. What have we got? 7 bracket 5 minus root 2 all over 5 times 5, 25, minus 5 root 2 plus 5 root 2 minus, because of the positive multiplying the negative, minus root 2. So 7 bracket 5 minus root 2 all over 25 minus 2. That is 7/23 of 5 minus root 2. And we've rationalised the denominator. We'll try one more. Now in this one, you can see that the numerator is a little bit more complicated. Remember that the numerator and denominator are both technically inside brackets, and give this one a go yourself just now before I go through it. Pause the video. Okay, multiply by 1. I want to get rid of the surd in the denominator, so I'm going to choose to multiply by 4 plus root 2 in the denominator and by the same thing in the numerator. And I'm going to remember that there are brackets around all of these. What have we got? I'm not going to expand the numerator for the moment. I might later on, but I said earlier, generally it's not a good idea. I'll explain why in a minute. So the numerator is nice and easy. The denominator, 4 times 4. Now you should be getting used to this. Plus 4 root 2 minus 4 root 2. That's going to make 0. I'm not going to bother writing it this time. Negative times a positive makes a negative root 2. So the same brackets in the numerator. We've got 6 plus root 3, 4 plus root 2, all over 16 minus 2. That's 14. What we've got here is an invisible one on the front of the numerator. We've got 1/14 of 6 plus root 3, 4 plus root 2. I think I'll just leave it like that. Again, we've managed to rationalise the denominator. What we're going to look at here is how to simplify a fraction that involves algebra in the example that I've got on the screen, or perhaps a fraction involving surds, something complicated. Now, if we were asked to simplify the fraction that you can see here, a lot of people, I'm afraid to say, would just say, oh, there's an x squared, there's a 16, let's cancel different things, let's perhaps do something like that. We get something like 8x over negative 1, the answer must be negative 8x. People will tend to say something like that, and it could not be more wrong. It's awful. It's as bad as taking the fraction 47 over 48, noticing that there's a 4 in both of the numbers and saying that it must be 7/8. It's just as bad as that. It's absolutely terrible. Okay? You cannot go that way. So let's go back to the original example and consider what you must do. X squared plus 8x plus 16 all over x squared minus 16. And perhaps before we do this, it would be worthwhile just considering how you cancel what you might think of as a normal fraction, a numerical fraction. Let's have a look at something as easy as perhaps 4/8. Now you know as well as me that that makes a half. But why? Have you ever really thought about why it makes a half? Well, we can factorize 4. We can factorize 8. We notice that they have a common factor of 4. And so the answer is a half. We factorized the numerator, we factorized the denominator, and then we cancelled. We cancelled when we had a string of multiplications. That is how you cancel or simplify any fraction. It doesn't matter how complicated it is. I'll repeat it. You factorize the numerator, you factorize the denominator, and then you can cancel any common factors. That means the only way to handle this is to factorize the numerator and factorize the denominator. So you need to know how to factorize a quadratic. Different people have different methods, but you should be able to get that for the numerator. This is the difference of two squares. This is x plus 4, x minus 4. And you can see now that we have a common factor in the top, which is also in the bottom, x plus 4. So I can cancel that with that. The final answer is x plus 4 over x minus 4. I cannot go any further. I cannot cancel these x's. I cannot cancel these 4's. Why not? Well, let's take a look. Suppose I had 9 over 1. I could think of that as 5 plus 4 over 5 minus 4. Is it possible to cancel those 5's? Is it possible to cancel those 4's? No. So it's equally not possible to do any cancelling here either. You must have a string of multiplications, just as we did in this numerical example here. A string of multiplications, then you can cancel. If it's not a string of multiplications, you cannot cancel. Now, last comment for this video. It was only possible to simplify when these were factorized. Therefore, if you are provided with a fraction where the numerator in particular is already factorized, this one wasn't, but if it had already been factorized, it would be silly to expand it, because you might need to cancel, you might need to simplify, and in that case you need the numerator to be in brackets already. So why would you take it out of brackets? Leave the numerator factorized, and it might just help you simplify the fraction. I hope that was helpful.